Hello everyone, welcome to IG Bits. We train, you learn. So how are you guys doing? Good to hear. Great. So we shall continue Newton laws of motion, but we will be looking at a few more cases of the problems as well as the following the few concepts today. Okay. So without waiting, let's get started. We created a YouTube channel. Visitors at our YouTube channel at the rate IGBits. Feel free to subscribe the channel. We started uploading all our sessions in YouTube. You can utilize this opportunity and build your competency. All right. Yeah, thank you. Last class we reviewed Newton's laws, right? uh, Law of motion, the first law. Basically it talks about inertia of rest and inertia of motion. We also talked about linear momentum, and then we discussed about a impulse, a force into time, and then we also looked at the few sample examples, and then we looked at a second law, the force law, a vector law, and then Newton's third law, right? This is what I think we studied. We also spoke about equilibrium of a particle and concurrent forces when net external force acting on a body is said to be zero. Yeah, things like that we looked at high level. Let's look at this problem. A body of mass pi case is acted upon two perpendicular forces. What are the forces? 8 Newton and 6 Newton. So what is given? Two forces are given. Right? What forces are those? Are perpendicular forces. So probably how do you read when you say perpendicular? Probably one is Fx, other one is like Fy. Right? What is an Fx? Maybe 8 newtons. Fy 6 Newton. So you can imagine when you say perpendicular, how do you think you have to be somewhere else like this? Right? So 8 newtons and 6 newtons. Since we are only calculating like the magnitude and direction, so probably the resultant is what they were asking in a way, right? So that if you calculate the acceleration, what exactly you needed? F equal to ma, right? Then a equal to f by m. So you need a net acceleration. So the calculation would be resultant. Fn is what you have to calculate. So if it is a 6n, and obviously this is a right angle triangle, I am giving a parallel line. This should be 6, is it? So one is like Fn, other one is like this theta is what you need to calculate. How do you get a Fn here? Fn equal to right angle triangle, no? So Fx whole square plus Fy, y component whole square, right? So the value would be 8 square plus 6 square. How much? 64 plus 36 under root. So that means 100. So square root of 100 is 10. So this would be your 10 newtons. This is the resultant. Now, how much value A? A would be F net by mass. So 10 by how much mass is given? Mass is a 5 kg. Correct? So this is a mass. This is a 5 kg. So you have to keep 5. Then what you get? 2 meters per second square is the units. You must be remember that. So what about the theta value? Theta value? Theta would be, if you can say, cos theta. Let's say cos theta is how much? Base is 8n by hypotenuse 10. How much this would be? 4 by 5. If you look at in a right angle triangle, a 3, 4, 5, 3, 4, 5 triangle, what would be the angle here? This is a known problem, right? How much? You're right. This would be 36. Theta value would be 36.87 something, right? It's the degrees. So now since acceleration in the direction of the force, right? The magnitude and direction of an acceleration is what they needed. So we calculate the magnitude. If you know the direction of the force, obviously you should be knowing the acceleration of the force too. So the answer would be acceleration of the body is 2 meters per second at an angle 37 degrees. Approximately, this is what a 37-degree triangle, 3, 4, 5 triangle. So 37 degrees with the force 8 newtons, because we are talking about 8 newtons. That is what you have to say. So your answer would be acceleration 2 meters per second square, okay, at an angle, how much? 37 degrees with respect to 8 newton, right? So 8 newton force. That is would be your answer. Are you clear? It is very simple, concept based a problem statement. If you look at a basic forces, what are the forces we have and then how we are going to leverage this concept in solving the problem. Let's assume we have the block of mass m which is at rest on the table. This is what the table, right? So what we are saying is that acceleration due to gravity and acting on the body is g, right? G is an acceleration due to gravity. So we know the weight. How do you get a weight? Mass into acceleration due to gravity. So m times g is gives rise to your weight. Always g towards to downward direction. So this way the weight is mg which is acted towards to down. Correct? There is a normal force also acting on this body, which is opposite to your weight. So that would be upward direction, right? Normally we can call it as a Fn. In our case, body is probably at a rest. So then what would be your normal force? Your normal force would be m into g, because you are balancing the forces, and hence the state of the body remains in the same state. We will be getting like a sort of problems to solve these cases. So currently it is in rest. If you talk about a uh, applying some force to it, like what would be happening, those cases also we will take a look at it. So let me say a case one, what we discussed. Case one, body is at rest. What we are defining is net force acting on the body should be the zero. So we have a downward force which is mg called weight, and then we have a upward force which is nothing but your normal force, contact force, Fn. So the Fn net force, how do you get it? Fn minus mg equal to 0. So Fn equal to mg. This is what you are saying. When the normal force equal to mg, this means like a body at rest. Let's look at a case 2. In case 2, what you are saying, you are trying to apply some force to lift this block of mass m to upward direction. You are applying upward force Fa, let's say. Then see, Fn is upward direction, Fa is also upward direction. That means your movement is upward direction. So your acceleration would be on upward direction. So if you try to see what is your Fa, so Fa would be Fn minus mg, right? Because that is where you get the same direction. Your value like this. Clear? So the Fn equal to how much? Fa plus mg. We all know what is Fa? M into A plus mg. So if we say calculation M A plus G equal to your normal force. So when you are applying some force to lift the block, then your net normal force would be M into A plus G. This is what one more you can remember. You will be getting like some problems where you can apply these to solve them. Are you clear? Beautiful. Look at this example problem. Who is going to help me to answer? A rocket with a lift of mass 10,000 kg. So what is given? M equal 10,000 kgs. Is blasted upwards with the initial acceleration A equal to 5 meters per second square. Agree? She is asking find the initial thrust of the blast. What is the F value? So make a note. Don't look at just F is equal to ma is sufficient for solving this problem. That is where we make a mistakes. So we are talking about the mass is lifting upward direction. There should be a mg acting on the body downward direction. So you have to be clear. So let's say you have a weight. This is m, and then the downward direction is what is happening? Mg, right? Acceleration due to gravity. Due to acceleration due to gravity, the weight is pulling downwards. But applied force is like upward, right? And then acceleration towards the upward direction. That is what is given. So how do you solve this problem? You have to put a equation. So using a Newton's second law, how do you get a net force? Net force is nothing but your F minus mg would be your ma, correct? Because this is where I think your F equal to ma will come. So I would say probably this F minus mg equal to Fa, right? Fa. So now F equal, if you can take this out, ma plus mg. So common m, a plus g, right? This is what your net force. So you have to calculate using this formula for the force in our case. Okay, ma is not sufficient. You have to add plus mg as well. So what is m value here? 10,000. What is a value here? A given is 5. Maybe you can take g is 10. So because g actual value is like around 9.8 meters per second square, right? Approximately this is 10 meters per second square. We can take it. So I would take 10. Then what would be answer? This is how much? 10 to the power 4 into is 15. Isn't it? So your value would be 1.5 into 10 to the power 5 newtons, or 15 10 to the power 4 newtons. Clear? This is your answer. Isn't it a nice problem? Good. If you look at this example, a man of mass is 70 kg, okay, standing on weight scale. Maybe there would be a small weight scale, right? And then assuming that you are standing like this, and then we know 70 kg. So this weight scale has some kind of reading. So probably you are actually looking at like what is this reading. But interesting part is this is whole setup is actually in the lift, right? Lift is moving with uniform velocity, uniform speed. So your u would be 10 meters per second. This is uniform. Agree? When you say uniform, what would be the acceleration A? A equal to change in velocity by time, but change in velocity would be 0. Initial, final, everything will be 0, right? V minus U by T. V equal to U equal to 10 meters per second because of uniform velocity of T would be 0, right? So really the lift direction is not impacting on your weight. That is what he was saying. So if you look at a simple a diagram, let's say your reading value, your you know lift value, you can say FA, and then your downward direction mg weight, right? If you can balance it, if since a equal to 0, your FA would be 0, and hence all you need is like Rw minus weight equal to 0. So Rw reading on weight scale is equal to your m into g, but reading scale normally normalized to g, and hence you will get actually the mass of the your body. So 70 multiplied by g into g. So done. So what you get is like 70. So your reading scale should show only 70 kg. Clear in this case? If there is a non-uniform speed, then the value will vary. That is what most likely the case to which you can think of. Are you clear? This is a good concept. Okay, let's look at this problem statement. A man of mass 50 kg, m equal to 50 kg, I'm noting down, right? On a weighing scale in a lift which is moving downward direction. If we say this is a block of mass 50 kilo, right? Then your reading would be up force upward direction, your mg would be downward direction, but you are also saying you are going downward direction with a, isn't it? A equal to 10 meters per second square is what is given. G you can take one more 10 meters per second square. So according to second law, how do you write this? How you can write a formula? So because of this downward direction, the net change would be mg minus r equal to force with acceleration, lift force, right? Fa. This is nothing but ma. So mg minus r equal to ma. So r would be how much? Mg minus ma. So you can take m common, then g minus a. How much value? M into 10 minus 10, which is nothing but 0. Right? So on reading, what you get is like 0 reading. So this means acceleration, uniform acceleration of the lift is 10, g is also 10. So there is no scale reading that you can see now. Let's say in your case, if your acceleration due to gravity changes instead of 10, if let's say 5, if take the case 2 out of problem statement, but in case 2, let's say a equal to 5 meters per second square, then what this value would be, r value would be m into 10 minus 5, which is nothing but m into a, m into 5. If m is 50, 50 into 5 is what you get, right? Ultimately, the reading value will come on the weight scale would be divided by your g value. So 50 multiplied with 5 divided by 10, then you get 5 into 5 is 25. 25 kilo is what is getting. This is case 2. In your case, a equal to 5 meters per second square. Case 1 and case 2 का problem statement, right? So acceleration due to gravity and acceleration of lift, both actually creating a decision factor in looking at your reading value on scale. Nice problem. Similarly, there is one more concept. Let's say you have the block of mass m, which is tied to the roof, hanging on this point. So what it sees, like the force due to the string is what you can call it the tense force, which is called the pulling force. Agree? In our case, we have three cases we can talk about. What happened when a equal to 0 means like when there is no acceleration applied on the body, a equal to 0. The second case would be a is equal to downward direction, and then a equal to upward direction, right? These are the three cases that we can think of. So in generally, the formula that you can say T equal to mg, right? In this case, when a equal to 0, right? So let's talk about these cases now. Case 1. How do you say? Your tense is an upward direction, your mg is a downward direction, right? And then you have an acceleration which is also upward direction. Think about, when net is upward direction, you always start upward force minus your downward force. Clear? So upward minus downward. How do you take a formula now? T minus mg would be your ma, acceleration with the mass. So T would be now m of g plus a or a plus g. Correct? This is one case that we have to see. So what if it is a downward direction? Case 2. So let's say this is a case 1. What about the case 2? Case 2, if it is a downward direction, A is a downward, this is T is upward, mg is downward, m. So net force here is a downward direction, so obviously this would be the higher value, right? mg minus T. mg minus T would be your ma. Then T would be mg minus a. See? So it's a simple, you are adding weight, you are adding ma to the mg when a body is moving upward direction, and then block is moving downward direction, then you are subtracting. So you will get like, you feel like little weight here, you feel like a little losing weight in the downward direction because of g minus a factor. Are you clear? Let's see, I think this problem statement now and how you are going to do that. You try out, otherwise we can try in the next. Okay, try out this problem statement. So you have a block, m is given, which is a 50 kgs, right? And hanging from a rope. Nice. So what you get is like a tense force. Tense. So in case 1, what is the case 1 that talks about? Well, let's talk about formula first. In generally, right? So T minus mg, case 1, what it says? Acceleration is 0. This means tense equal to mg, right? Tense is upward direction and then mg is downward direction. So both should be equal when acceleration is 0. So T is equal to mg. So m into g. M value how much? 50 kilo. M equal to 50 kg. Right. So g would be 10 meters per second, you can think. So mg would be 50 into 10. So 500 newtons. That's the case 1. Look at a case 2. So what is the case 2? A equal to 5 meters per second square, downward direction. So when you say downward direction, so ma would be this side, right? So then you have to start with mg. Mg, your net force would be according to Newton's second law, mg minus t. So mg minus t would be your ma, right? So density would be how much? M into g minus a, and hence m 50, how much g? 10, a 5, so 50 times 5, 10 minus 5, 5, right? So 250 Newton. You see the difference? When downward direction, you feel that like you are losing some height. That's what it says. Case 3. What is the case 3? A equal to 5 meters per second square would be upward direction. When it is upward direction, your net force would be T minus mg is equal to A. T minus mg equal to A. We are considering, the directions. That's why, I'm starting based on the net direction, the force would be a starting reference for me. So T minus mg. So what is the T value here? M into g plus A, and hence 50 times 10 plus 5, 15. So 50 into 50, so 750. You feel like you're gaining more weight when you're going upward direction. Agree? This is how you will be, calculating, when you have these kind of problem statements. This is one of the best example I think you should remember. Thanks for watching. Please like, share, subscribe, click on bell icon and leave the comments. Folks, we reached end of session today. Thank you all who have joined today's class. I hope this class is very useful. We have some more cases which we are going to take a look at in next class. Stay tuned to next session and have a good day, and then all the best for your daily planner preparation. I'll see you again. Thank you. See you tomorrow.